Well, the world's most powerful space telescope on Saturday blasted off into orbit, headed to an outpost 1.5 million kilometres from Earth after several delays caused by technical hitches. The James Webb Space Telescope, some 3 decades and billions of dollars in the making, left Earth bound for an historic mission. Joining me now live is astrophysicist and cosmologist at ANU, Brad Tucker. Brad, good morning. Look, this was extraordinary over the weekend. Can you firstly explain to us what is the aim of the mission itself?
Yeah, look, it was a good Christmas gift because, we wanted it all open, and it was so far. So the James Webb Space Telescope is designed to look further and at fainter objects than what we can currently see with the Hubble Space Telescope. The limit with telescopes is how big the mirror is, essentially. They're giant light buckets. And so the bigger the bucket, the fainter or further light you can see. And since the James Webb is much bigger than Hubble, it will be able to see fainter objects in space. Now, fainter obviously or either means further away, so things much towards the edge of what we can see in the universe, or we can see closer objects, but that we would normally have missed. Or if you can already see the object, you get more detail. You get that better resolution because of the power of the telescope. It'll also look at other colors of light that Hubble can't see. So really looking at how the first galaxies formed, how the first stars formed, what caused the very first black holes to get as big as they did, directly imaging planets around other stars, potentially looking for signs of life. These are all jobs and tasks that James Webb will do, plus much more.
So will it be sending us back pictures, so to speak, Brad, and how long will that take?
Yeah, so it'll be taking both images and detailed measurements, what we call spectra, which is kind of like fingerprints of objects in space. We can see what elements are present there, and that's going to be really useful for looking for biosignatures, signs of life on exoplanets, planets around other stars. Now, when it gets to its final orbit, which will be in about 27 days, it will have a series of tests, essentially, to boot up all the instruments and get ready. And that will take about 3 months. So from about 4 months' time from now, we'll start to get data from the telescope that will come back to Earth. And there will be a slight period of kind of commissioning, testing, making sure everything's running fine before it enters regular operations middle of the year. And from there, we'll get streams of data back like we do with Hubble. And the images will be even crisper and more detailed than what we've seen with Hubble. So for all those amazing images we've seen with the Hubble Space Telescope, it's kind of like going from 1080p to 4K. We're about to get the 4K version.
Oh, we're excited about that. And just for comparison then, how does James Webb compare to the Hubble telescope?
Yeah, so the Hubble Space Telescope is 2.4 meters across. So that's the width of the mirror, and that's really what determines how big it is. The James Webb is 6.5 meters wide, so it's 3 times wider. But because it's a circle, the power is actually much more than that, over 10 times more powerful than the Hubble Space Telescope. So everything will be much more detailed. And also, so the Hubble's contained to looking at optical colors we can see with our eyes, plus a little bit into the ultraviolet and the infrared, so kind of surrounding there. The James Webb Space Telescope will be able to see far into the infrared, so like cricket vision or night vision, even thermal vision, so to speak. All of that looking at objects. So even objects that we've seen before, we will get a lot more detail and see it in new ways than we've previously seen compared to Hubble.